So this is actually an interesting project for me because it essentially connects two kind of areas of research that I'm working on. I started out more or less with classical public economic questions surrounding taxation. That was my PhD, and then I grew into this kind of regional economics, spatial data world quite a lot. And for quite a while that run parallel, I had still some public econ questions that I tried to look into with the spatial data, but I never had the combination of taxation to some extent with the spatial data before. And at least to some extent, this is the first paper, first work that I'm doing where I try to cross these kind of two disciplines. Because at least in the economic application, I will talk a little bit about the taxation of multinational firms here as well. But this is essentially the application. The main part of the paper is more or less the question whether we can use geospatial data, specifically nightlight data, to measure firm activity. So what the central idea here is to use this idea that exists in the economic growth literature already for quite a while, that you can measure economic activity by looking at certain areas and see what kind of light they produce overnight. Can we use this idea basically to go into the micro level and look at firms, right? And this is essentially the main point that we try to tackle here in this paper. When talking about we, I talk about Katarzyna Belinka. I worked with her before. She's from Utah State. She is also part of NBR. And we both worked on taxation and corruption before, and now we're basically teaming up for this kind of endeavor. Okay, so this was a small introduction to this kind of, there we go, to the kind of major framing of the paper. Ultimately, we are asking the question how much we actually know about firm activity around the world. And it sounds like a ridiculous question to start with, because you would argue, well, we know a lot, but actually it's not really true, because what we know about firm activity from a global kind of perspective typically comes from very questionable data sources. So we have financial data, we have stock market data, but already there everybody would agree that stock market data is not really telling you something about the specific activity of a firm in a specific location somewhere in the world. So the data that we mostly use there is accounting data, right? Because Bureau van Dijk provides us via the Orbis database with essentially the assets, employment, turnover data for subsidiaries of many firms globally. And then you more or less could say, okay, now we know, for example, what Siemens in South Africa in a certain province has as economic activity. So far, so good. But the problem is that this data is questionable in many regards, because ultimately, the first question would be, is accounting data really reflecting economic activity, or is that not really a kind of technical kind of description what is going on that is biased by a lot of issues? For example, different accounting standards, also ultimately different depreciation rules. How to evaluate a factory that is 20 years old, it's a very debatable kind of thing in all the countries around the world. We try to basically unify these kind of things quite a lot for the last couple of years, but they were still far away from complete standards. So this already makes this data problematic to use if you want to say, okay, this is the economic activity of a firm in a certain region, and if you think about the kind of economic applications, what's the environmental impact, given that they are big or small, questionable or problematic. And the biggest problem is actually that besides this noise that comes from this kind of different ways of measuring economic activity and accounting data, you have also opportunistic reporting behavior, right? So we all know that multinational firms are always accused of basically hiding certain kind of amounts of profits, essentially also partly from the public eye, because they have kind of profit maximization ideas, and you can maximize profits if you more or less let profits occur where taxation is very small, right? So this kind of opportunistic reporting behavior is a big issue, because this creates fundamental systematic biases in the data. So we come up with the kind of idea motivated by that, can we do better? And can we do better? We basically try to figure out with this idea that we use daylight satellite images to look at production sites of industrial firms, and we measure basically how much land they consume with their factory buildings, and we look how much light they emit overnight. And we basically argue that this could be a potential new, globally available, unbiased, at least by opportunistic reporting behavior kind of ideas, measure for firm activity on the ground. This is what we're going to do, and this is basically triggered by this very large literature on basically economic growth and the nightlight data usage. When I'm talking about firms, I specifically in this project talk about car manufacturers. To be honest, or not to be honest, to be precise, we're talking about the 19 largest car manufacturers and Tesla. Don't ask me why we included Tesla, but it sounded fancy at the time. They are not on position 20, I can tell you that. We, for various reasons, look at this industry. The most important one is that they're really easy to identify, basically using geocoded data, because they are bragging quite a lot on their websites about where they are producing and how big they are, and you can combine this data very nicely with basically accounting data and remote sensing satellite data. So this is the main reason why we started with the car manufacturers. We basically use this data and combine, or this data on the light emission of these car manufacturing locations, and we combined it with two different data sources. One are COVID-19 pandemic shocks, and the other one are essentially financial accounting data, so this data that is questionable. So we use that partly to see whether the data correlates, but also to analyze to some extent in economic application what's driving potential differences between this kind of independent measure of economic activity and the accounting data activity. Okay. Again, already speaking about economic application, I try to convince you that we can use this nightlight satellite data to proxy economic activity of firms to some degree. There are some caveats that we have to be honest and straight with about. But then we basically say, okay, let's take this and do some economic applications. And the two we are actually aiming for is one that is associated with this reporting of multinational firms. So I will show you in the end a map that basically shows you where firms are very intransparent, and I try to tell you a story about that this is not random. So there are potentially some strategic reasons why accounting data, for example, is missing, and also why potentially accounting data and this kind of external remote sensing activity indicators deviate from one another. This is one of the applications, and the other one basically is more of a kind of technical application where we ask, when we look at nightlight data, what we're really measuring. So we'll try to make the point that industrial and urban lights tell a different kind of story, and we should be aware of that if we, for example, use nightlight data in the estimation of economic activity for regions. Then it's important potentially whether we're looking at a region with a lot of industrial activity versus a region without. Okay? So, data. I already told you a lot about the data. Essentially what we're using are daylight satellite images provided ultimately by Google Maps, and we combined it with OpenStreetMaps data to get the locations of factories. If we have these locations, we basically geotag them. I show you a picture in a second of the footprint of the factories, and then we measure the light they emit overnight, and the nightlight data we're using is the VIRS data. So the newest generation of nightlight data, which has a very high resolution of 15 arc seconds, so roughly 500 by 500 meters. Also a reason to go to the car manufacturing industry because they are big. So the kind of resolution issues here are potentially slightly less of an issue. We use for the yearly data the newest version of the clean data provided by Eldridge. For the daily data, we have to use the raw nightlight data, which we ultimately then also have to combine with cloud imagery to basically test whether our data is not biased, for example, by cloud coverage. I come back to that later. Again, I said we're using COVID-19 production shocks. More details on that later. The data source for that is just auto.com without making any advertisement here, but we needed more or less various sources to figure out when factories had to close down in 2020, and this website provided quite a lot of this information. And again, the last data source is basically this Orbis data provided by Bureau van Dijk. We have access to data from 2012 to 19, and we match that essentially with the nightlight data through the websites of the car manufacturers. So car manufacturers are really on their website tell you, okay, we're really a big employer in a certain region, there's our factory. They give you an aerial picture of the factory that already tells you a little bit how the factory looks and what they perceive to be the main complex of the factory. And then they tell you also which subsidiary this factory belongs to, which is super important because now we know where they produce, we have an address to look up in Google Maps, and we also know the ultimate, or we always know the ultimate owner. It could be Volkswagen, for example, but we also know to which subsidiary of Volkswagen they belong, which allows us to match that then to the accounting data, because in the accounting data we then know, okay, the subsidiary of Volkswagen in this specific region of Spain, for example, has this amount of assets and potentially 2 factory locations. Okay? Just to give you a bit of a kind of practical view on what we're doing. So imagine we search for Volkswagen, we search for Volkswagen Saxony, which is a state in Germany, and this is also the name of the subsidiary of the car manufacturer. So Volkswagen has several different subsidiaries within Germany, and one is basically called, like the state, Volkswagen Saxony, and they tell you we produce in 3 different locations. One of them is called Mosel. And in Mosel, essentially, when you Google that, you will find in the daylight satellite images this pretty very nice picture. So this is where they are producing. And without using any kind of cataster, land registry data that is very complicated to get, we now can basically, in the daylight satellite images, say, okay, the red area is essentially the area that the factory is occupying. So this is the kind of very best kind of case scenario, green land everywhere around, you really precisely know that's the factory. Obviously, this kind of process becomes more messy if factories, for example, are in larger industrial agglomerations closer to cities. But the current resolution of daylight satellite images allows you to a ridiculously large extent to more or less use certain landmarks to figure out what belongs to which factory. So essentially what you can do, you look for the main entrance of the factory, and then you basically walk around the fence, because these production places are all fenced. You can also look at these connections between industrial buildings, so if they have a pipeline going from one building to the next, even if there's a fence in between, they are probably connected. And on top of that, OpenStreetMaps and Google provide you tags that basically tell you, okay, it looks, for example, in Vigo, you have the big former Citroën factory here, and most of this kind of factory area actually belongs to now not PSR anymore, but the follow-up conglomerate since last year. But there's also a small part of the plant that belongs to a different kind of subsidiary that produces, I think, the drive shaft of the cars. And in Google Maps, you see, okay, there's a different name tag on it. Then you look closer and you see, okay, they are within this industry agglomeration, but they are not really physically connected to the main plant of the car manufacturers. So this is pretty detailed work we're doing here. And ultimately, after we done this geocoding, we can measure the nightlight emitted over these kind of factories, which would be the picture to the right then. So this is much labor, quite a labor-intensive kind of work. We ended up basically with this map that made us very happy. Those are all the car manufacturing production sites, locations of these 19 biggest car producers. And the map basically shows you very nicely that, of course, you have a huge agglomeration in Europe and North America, but car manufacturers have basically subsidiaries and production sites all over the world, utilizing essentially potentially cheaper labor. In Africa, it's a lot in South Asia, but also in South America, right? And somewhere there's also Vigo on the shore to the Atlantic of Spain, right? Okay, we did the data the kind of data collection in several stages to basically be sure that we don't introduce biases. So first student assistant, so the first data we collected ourselves, then we let student assistant collect one wave, then we basically gave the same data set without giving the data set we gave the same task to the second cohort of students that collected for us basically data again, then we combined them, and ultimately we had to, because there were still a lot of mistakes, do a lot of the data work ourselves, and we could actually, that's what one research assistant did in the end, also get a panel data set out of that. So with basically the older satellite images, you can also see how the factory has changed over time. There are some certain limitations to that. But you can actually, if you already know what the maximum kind of land consumption is that they have, you can use the older data to see when they started growing. The older data has smaller resolution, so there's a certain bias that could come from that, but we basically have this data as well. Just to give you a brief kind of idea what we ended up having in our data set, we had 923 factories that we geocoded. They're approximately half a square kilometer large. They emit a light of the level 26, so this is the radiance scale that you typically have in the nightlight data. Just to give you a reference, the kind of core of major urban agglomerations is typically 64. So the center of Moscow, for example, is 64. So they are not ridiculously bright, but they're also not very dark spots, right? We have to combine this kind of data with the accounting data at some point. And just because we are at descriptive statistics here at this point, to already give you an idea on what happens then is essentially that, first of all, we have to clean the accounting data from the most ridiculous kind of outliers. So in the accounting data, or using accounting data, you typically winterize to some extent to get these really big, strange data points out. And if we then combine it with the factory level data, we end up a bit with the issue that an average, one subsidiary owns two plants, so we have to merge basically the light emitted from one plant with the light emitted from another plant, and this is then the light emitted by the subsidiary, so to speak. And then we obviously lose half of our observations because two factories make one subsidiary, and the biggest problem is actually then you face this kind of missing issues in accounting data. So we ended up, for example, with turnover with a sample of 300 firms in the end, where we have basically turnover, accounting data, and our nightlight data. And this data set then looks a little bit different. We have slightly bigger areas, which makes sense because we combined two factories, and on average they are slightly less bright, but not ridiculously far off from one another. Okay? So this is the COVID-19 data. Just to give you a bit of an idea what happened in 2020. In 2020, car manufacturers had to close their factories to prevent the spreading of COVID-19. I was in the US somewhere in the beginning of the scale and had then to leave the US because of all the mayhem that happened at this point. And basically after I left, all the car manufacturers globally had vaguely around the mid of March, more or less, to shut down the operation at least for 2 weeks. There are some that are a bit earlier, those are the ones to the left. This is Asia, and there are some a bit later to the right. This is, for example, South America, that then were also partly closed down due to the fact that they were missing parts. Okay? So this is the COVID data, and given that we are with the COVID data, we are basically starting now. We can now start with the kind of first thing we want to check with the data. So sure, shoot.
Yeah, you make a good point. There has been this aggressive shutdown. Yes. Mm-hmm. So during COVID-19, we agree there has been this aggressive shutdown. Mm-hmm. Many plants closed down entirely. But before that, there were some plants that had to restructure themselves, so they had to cut down operations. Mm-hmm. Do you have that also in your data, and can you account for that?
I will show you basically a dynamic estimation where we look at the weeks before and after the closure, and on average we basically see no large effects before the closure. Okay. So if what you say is correct, we should basically already see something before, which we don't see. What we definitely see is the aftermath. So most of them, they were supposed to be shut down, but ultimately they not shut down for a month. They typically shut down for 2 weeks or something like that, and then they slowly started producing again. For example, to produce masks and these machines you need to keep people breathing, essentially.
Yes. Right. And just another very quick question. Also, you have shown us a great map of locations of producers. My question is, have you considered also the regulations? Because I guess that, for instance, cars made in Europe, they have a certain type of regulation by which the plant may not close, but still there are less activity on Sundays, for example, because people usually take a Sunday off, or well, they make these shifts so that there may be time like high peaks and low peaks. Can you account for that properly with the data you have?
In two ways, essentially. I'm telling a lot of the story that comes in a couple of seconds, but essentially to quickly respond to that, ultimately we will look at weekly data and the dynamic kind of estimations, which average out to some extent these kind of differences. And essentially what we're doing identification-wise is we use the same plant a year before as a reference group. And with that, ultimately, we get these kind of seasonality things, this local cultural kind of differences in production out of that quite a lot. Okay, told you already a bit of the story that comes next with that. But first of all, let's just really focus on the essential question that we're trying to look at here. So if you speak with people in the growth literature and you tell them that you really go down on this kind of micro level, they all are very skeptical because they know the resolution of this data maybe is a problem, the data is noisy. So the first question really is, do we see that the change in economic ground activity, so the production of a firm, has a significant effect on the light emitted? So this is really the quintessential kind of definition of economic activity. Really do something. It's not just assets on the ground that are illuminated because you want to provide theft. It's also really that people go in the factory, they drive around in the factory in the night. There's basically parts of the factory that are brighter illuminated because there are people really in the buildings working, right? So do we see, can we measure that with nightlight data, right? And this is an important question, and that's the one we try to tackle here, because COVID-19 really offers us this opportunity, which is also quite unique in a sense in the nightlight literature, because typically what we have done before is look at, for example, the effect of natural catastrophes on a light emission. But there we also have always the same things happening simultaneously. We have the natural catastrophe that it destroys assets, and then also you have less labor employment basically on the ground at that moment. But with COVID-19, it was just like, okay, from now on, we don't work anymore. Right? So we know that this is a 100% reduction essentially in labor on the ground. And we want to know how much does this changes the light, and this is where we can use the COVID-19 data. Right? So the critical assumption here is that really that they did not think, okay, we need to tear down the factory now because of COVID-19. They really just said, okay, nobody's supposed to work anymore for at least 2 weeks. And this is what we're trying to utilize here to really get to this kind of causal relationship between ground activity, production activity, and nightlights. We do that basically in two different ways. We use a very simple difference in difference approach where we have just a dummy that tells us, okay, now they needed to close down. We have daily data. And then we basically, as a difference, look at the same factory, basically the year 2019, and compare that to 2020. This has various advantages, for example, because we can mean out these kind of firm fixed effects, these cultural differences in production, but also this cycles that could potentially be a problem here. So imagine that in March, for whatever reason, in some countries there were a lot of public holidays, and therefore this is very natural that production goes a bit down in this. This should be out. Most importantly, we also get with this methodology out that you have don't worry. You have with this kind of, so that the raw daily data has a lot of noise coming into that. For clouds, for example, because of clouds, but also for stray lights. So moonlight, for example, but also the kind of position of the satellite in comparison to the sun and the moon more or less can affect these kind of measurements to some extent. And if you basically compare it from one year to the next, at least partly you get that out of the data. Also, it is a fact that potentially it's slightly darker in Norway, for example, around midnight in comparison to Spain. So you get all of these kind of measurement stuff out with the difference in difference kind of approach here. Importantly, when we look at this estimate, we control for the kind of illumination around the factory, which is very important. We can also do a difference between the factory location and the surrounding of the factory, because we obviously know that close down or shutdown measures were also basically implemented in the civil life around the factory. So people did not go to pubs anymore, and with that nightlight also around the factory has changed. And we want to be sure that what we are measuring is not this kind of general kind of reduction activity at all in the economic society. So we control for what is happening around that. We can also do a difference with that, and then things look pretty much the same. What is typically the most salient point or to use here is essentially this dynamic kind of estimation where we really look at the weekly effects around the closure date, so the weeks before and the weeks after, where we still again look at the difference between 19 and 20. Okay? So just to show you some kind of estimate results here, if we really go with the very simple kind of approach and just look at without a difference, essentially at the effect of a factory closure, we see that 100% reduction in labor economic activity reduces in labor reduces nitrate emissions by something like 6%, right? We control also for cloud coverage, is also an important control. Due to the fact that clouds can also increase and decrease basically illumination to some extent. Most importantly, if we then basically control already for the surrounding light around the factory, around the closure time, we basically see that we really already reduce it to 4%. And we basically stay in the same ballpark if we then really look at the difference and look at basically the same factory and compare it with the same factory a year before. And really, again, we are seeing this kind of 4 to 5% reduction in light at in average at factories due to the closure, let's say, edict imposed by the governments at this time. Right? So we're talking about 4 to 5% here in average. We then could start asking, okay, is that really the truth? Because again, we already talked about maybe they closed a bit earlier, maybe they opened up a little bit earlier, so our dummy for basic closure is potentially wrong. So we started already more or less, and that's the last column, number 4 here, to basically reduce our sample to the week before and the week after, and we are again ending up with this kind of 4% kind of reduction, which reduces obviously our sample also substantially, because then we are just looking at the 2 weeks before and after.
Excuse me, the time span of your data is 2019, 20?
The time span of the data is basically early 2020, or no, it's basically January till June in 19 and 20. So if we are not using the difference in difference, we are sticking with the 20 data. If we use the difference in difference, we basically have these half year between 19 and 20. So as I said, we can use also this difference in difference in a dynamic kind of world and look at the effects the week before, comparing 19 and 20. And what we see here is that the weeks before, there is basically nothing interesting going on there. Somewhere the effects are somewhere at 0. But basically in the week of the mandatory closure or shutdown of the factory and the week after that, we see vaguely a 40% decrease in light. And this is pretty persistent throughout whatever model specifications we can do here. And then basically in week 2, you already see the effect going slightly up again. And in week 3, most car manufacturers, at least in average, seem to have already some kind of activity, and we cannot more or less say they are statistically significantly different from the year before and the kind of weeks before the closure, right? So this is pretty strong evidence that there's a causal link between the ground activity and what happens in the nightlight data. And sadly, the story is a bit of a glass half full, half empty kind of story. Because yes, we find this kind of causal effect. But if you think about it, we have a 100% reduction in labor activity on the ground, and we only see in max a 14% reduction in light. It really tells you that this kind of ground activity is a small proportion of the light emission of factories. The most comes from the assets on the ground, so what is really standing there, and this is an average always illuminated. So even if, I don't know, the factory in Vigo has to shut down for a couple of years, we will probably see that there is something there, because they will not switch off the lights, because then other kind of bad things will happen, right? So this is something we have to keep in mind when using this kind of data, and this should also moderate our expectations, especially related to panel data usage. Because if we really think that in a certain industry, a certain factory can over time predominantly change their output by increasing or decreasing labor, so do they run 1 shift, 2 shifts, 3 shifts? That's what a lot of car manufacturers did. They basically reduced the number of shifts in the beginning to basically cope with this missing input factors. Then we are probably having a bit more problems to see that in the satellite data, because ultimately the large proportion of the light is from the kind of assets on the ground. But if we look at really long kind of panels, we could expect that also the kind of panel predictive power of nightlight data increases again. But when I will show that later to you, what we advertise for here is that if you use the nightlight data on a factory level, the better choice would be to look at cross-sectional kind of variation here, because over time you potentially just have too little variation in the data, at least if you look at short time panels. Speaking about basically going into the next level and basically really try to predict economic activity, the next analysis we do is more or less using this accounting data and see whether we can predict that, or basically whether it's correlated with our nightlight data. The specification here is pretty simple. We are moving away from the production site level, we're moving away from the daily data, we're moving to yearly data on a subsidiary level. So again, this is the data where we have two factories belonging to one subsidiary, and we have this kind of accounting data, which is turnover, assets, and employment. We are focusing in on the paper on the left-hand side, and we try to explain it with the nightlight on the right-hand side. Pretty simple kind of cross-sectional slash panel kind of estimation that we are going for here. Importantly, we should already here have in mind that we expect that, or we have the suspicion that accounting data is potentially biased. So our expectation here should not be in the first place that we have a perfect correlation, because ultimately we expect that there is some kind of mischief or noise in the accounting data. But if we stick with the cross-section, so we look at these 300 firms, we look at the mean between 12 and 19 and look at turnover, assets, and employment, and look how they can be explained with country fixed effects and parent fixed effects. And the light they emit really can explain quite a lot. So first of all, we see always that we have this kind of 0.7% relationship. So 1% light increase typically corresponds to 0.7 increase in turnover, assets, and employment. And if we look at the R square, we're really explaining quite a large part of the variation of the variation here. And also the R within, so within the countries, within the parent companies, but also in the overall R square. So this is what we would love to see everywhere. And this is pretty much the kind of big salience point that the nightlight literature had on the country level growth kind of perspective, that there's a really very strong and good correlation, so you can use this proxy. And we see that this is here the case for a cross-sectional variation. But at the moment when we leave cross-sectional variation and go into the panel, things look slightly different. There, first of all, significant levels go down. Second, we are, however, basically estimating almost the same coefficient that we have in the nightlight, or that exists in the nightlight literature related to the relationship between GDP and nightlight, which is something like 0.28. That's the Henderson et al. Paper, more or less. That was the first one that became famous with the relationship between GDP and light. And they have almost the same coefficient. And they use not turnover, they use GDP. So that's pretty good. But if you look at the R square, so what can we really explain as on variation with over time within these, 8 years, 7 years, 8 to 7 years, depending on specification, is very little. Which again corresponds to what we saw before. If we really expect that they within a very short time span not very often change huge, basically the assets in the factories, it's just this kind of labor input-output thing that we could potentially capture here, and we know already that's the weak point of the nightlight data on this kind of small level, right? So the caveat here is that if we want to use on the firm level kind of light data, it seems to be a good choice for comparing firm size, but looking at firm growth, we have to be cautious. This could partly be due to the kind of specific industry or looking at the short time panel, so this is not ultimately the end of the story. I think there's something to do further on, but we are lacking the data to do more, right? But it's still, the correlation is positive, the coefficient is the same, so this is all in all pretty good news. So this is essentially what I said just in a written form already. And in the discussion, the point here is a little bit that we see that we have this better explanatory power in the cross-section versus the panel kind of setup. And this begs a little bit the question ultimately whether these kind of industry lights we are looking here at are systematically different than the lights we're usually looking at. So if we look at regional aggregates. And this is one of the applications we will basically later do, to dig a little bit into, is this something that we just see in the specific industry, or could that be a general kind of thing of industrial light emission, that they basically proxy a bit different kind of things than, for example, urban lights, right? Okay, I'm halfway okay in time, that's good. So this is basically the end of the main part of the paper. We try more or less to sell here that under certain conditions we can use this kind of micro level, firm level night light data to proxy for firm activity even on this kind of very small scales. Now we try to apply that. One application is basically to think about further about this kind of industry light thing. And with that comes the question, what do we actually measure when we measure nightlight? What is nightlight measuring? So in the kind of growth literature, essentially what we are using is the light emitted by a certain region. The region then, however, is not defined as the kind of areas that are built up, which in our case is the case. We're really looking at only those places where there is land use, right? So in the kind of bigger literature, nightlight potentially measures both things. It measures the land use, but also the land use intensity, right? Because there we cannot differ between the kind of land really built up and the land that is free. There we look at the aggregate light emission, because we're typically missing the data on this land consumption dimension. But we can do that. We really know what land is consumed, and we can look at how much light this land is basically associated with. And then we can more or less ask the question, what is nightlight data in a specific context measuring land use or also land use intensity? And with that comes the question, are industry lights different than urban lights, for example? Because in the urban light literature, I can already tell you, the story is that there you also measure a fixed kind of area, so that you know the urban area has land, or the land is used by the urban area, and there you see that light intensity explains quite a lot of differences between more or less one city and the next. So there the intensity thing seems to measure something. And I can already tell you, we will show that in an industrial kind of context that's less the case. There it seems to be predominantly that we measure land use rather than land use intensity. Okay? So the kind of estimation approach that we're running here then is to repeat the kind of exercise that we did before. So we have our accounting data, and we want to see whether the average light on the area, which is now just Allen light, so the second second variable measures output more than, for example, the land that they are occupying the area. So we're just splitting up the light sum into light area, the area that they are consuming and the light. And then we repeat the same exercise. And if we do that, we basically see, so the column 1 and 3 is basically for the cross-sectional, for cross-section and panel, the same estimates that we had before for turnover. Let's just focus on turnover for now. And column 2 and 4 do what I just described. Instead of using the sum of light that is affected by how big is the factory and how much light is emitted by the factory, we have just how big is the factory and how much light and average is there. And if we look at the cross-section, we basically say that splitting that up doesn't change our R squares too much, and basically the land area and light explain jointly more or less the turnover. If you really look closely, you see from the T values that area has a small edge over light here. But most importantly, if we go into the panel estimates, we basically see that explanatory power of light goes down quite a lot, and it's predominantly the change in area of the factory that explains turnover changes, right? And this is substantially different than from the urban literature, because again, there we see that comparing two different cities, keeping the area of the city fixed, we really see that this light intensity, so that the average light in the city explains the differences in the kind of economic activity between city A and B. But if we would do that here with industry, we would not see that with a high likelihood, because essentially light intensity seems not to be so important here. Now you could ask, okay, we're looking at a very specific industry. That's the car manufacturing industry. They don't reinvent the wheel or how to produce the wheel everywhere in the world in a different kind of way. So the assets on the ground are very homogeneous ultimately. There will not be a factory that is 20 floors high. It's always practically the same building. So it's not so surprising that when we measure area, we ultimately measure assets quite well on the ground, because the factories are basically everywhere the same. So what light still can explain is, again, this kind of difference in labor employment, and we know already this is not a big thing that light explains on the kind of factory level. So the question becomes, is this something we can generalize for larger industries that potentially have also different kind of asset intensity on the land they are using? And to check this, we're basically, or look into that, we're basically using the so-called GHS European Settlement Map that tells us where in Europe you have built up on a very small scale. And they tell you not just where there are buildings, they also tell you where there are residential buildings and non-residential buildings. So what we're doing here is we assume that all non-residential buildings are, to the largest extent, industrial buildings. There are some castles in there as well, but I hope that they are not really affecting our estimates too much. It's ultimately the industry land consumption that we can measure with this data. We can measure that for 2015, so this is again a cross-section, and we can measure that for Europe. And in Europe, we also can basically go on the municipal level, so the NUTS3 level, so the smallest kind of scale we can look at, and look at industrial GDP output. So we can combine this kind of industrial output measures with industrial land consumption and ultimately also the light that is emitted on these areas specifically. And that's the last thing we basically do in this kind of application. And what we see is surprisingly a very similar story. Again, we can only go into the cross-section, but we see again that the light sum as an aggregate tells us quite a lot in the cross-section about industry outputs in these subnational regions. So that's 3 regions in Europe. But if we split it up between light and the area that this industry is occupying, we see that area is predominantly explaining or explains most of it, and essentially the average light slightly less. So this really shows us that industry lights basically proxy something else. They predominantly proxy kind of assets and less so ground activity. And this is a substantial difference to what we see in the urban light literature. And this is something that we should keep in mind in many, many cases. So first of all, it tells us a little bit about how to use potentially the data. So if you don't have the nightlight data potentially available because the scale is too small, you may get land consumption data ultimately out of the daylight satellite images, and you potentially can use this. Most importantly, given that we see that nightlight is not equal to nightlight, we should think about, and this is again another kind of thought for future research, about when we measure economic activity on a regional scale, whether we should not consider what kind of light producers we're having here. Is that urban lights that dominate the light production in an area, or is this industry light? And this potentially can explain, for example, these kind of differences that we observe in the nightlight literature, that typically we struggle with rural kind of lights. So looking at more rural regions, we typically see a less strong correlation between lights. And this could be that we're missing these kind of urban agglomerations where light really tell you 2 things, land consumption and land intensity. And we have potentially slightly more of these kind of industrial area light producers where light more or less tells us how much there is asset on the ground, but less so how much this asset is utilized by land intensity, essentially, right? Okay, now comes the fun part of the paper, which is essentially associated with this thing I started out for motivational purposes in the beginning. So assuming that we have now these at least cross-sectional proxies for firm activity on the ground, we could think about, or could make the argument, we can now make a proxy for what kind of assets, what kind of turnover should be reported in a certain location, and then compare that with what they're actually reporting in this kind of accounting data. And this is what we call a bird's eye view on this multinational entity reporting structures. And in general, this is something where I think the remote sensing literature moves more and more to. We can use this kind of remote sensing data to cross-validate what firms actually tell us. In China, for example, they measure air pollution quite tightly and try to figure out whether firms comply with environmental regulations. And in our case, we would actually argue, does it make sense what they report in accounting? And this could be a tool for tax authorities, for example, to say, well, there's a big factory, you produce a lot of things, as it seems, there's a lot of light there, and ultimately you report you have almost no turnover, you have no profits. That's suspicious. We should investigate it a bit further. Okay, Yes, and if this is true, we could ask how large is this bias, how large are the missings, because we now also can look into these areas where we have no data at all, which was not possible before, and we can think about what are potentially determinants of these kind of missings in our data. Just to give you a little bit of an idea about how slightly less or more transparent these firms are around the world, let's have a look at this map. So the size of the circle is ultimately how big the car industry is in a certain land, in a certain country. And red means they don't report any profit data and accounting data whatsoever, and green means they report. So again, this is not tax avoidance. It's just like, for whatever reason, they didn't feel like really making it easy for Bureau van Dijk to collect this kind of data. Maybe they report turnover, but for whatever reason, they don't report the profit data. And this can be very convenient because you try to hide your activities to some extent, and this is a little bit the argument we are after here. Being slightly less transparent to the public makes it easier for you also for the tax authorities to manipulate your tax statement to some extent to save on taxes. What you see here is basically in the first term is not a systematic kind of pattern. It's developed countries as well as less developed countries where these kind of missings exist. What is most striking from my perspective is actually that you see also a huge variation within Europe. Because in Europe, you should actually have the kind of unified accounting standard. So this should be a place where they all report in a very similar way kind of profits. And still there you see in some countries, Bureau van Dijk was not capable of more or less collecting the data. And it's not because they are lazy. I talk with these people and I really say it sometimes, it's from the public statements that the firms make, it's very complicated to figure out what is what. And ultimately they have a limited amount of time, they are profit oriented, they stop at some point digging deeper, right? And again, this is something which firms could profit from. So let's run this as an estimate. Of course, this is just correlation, so we cannot here really immediately claim causality, but it's just an interesting kind of descriptive exercise here. And the question is, first of all, are missings systematic in firm size? We can look at that now. Is it the big firm that we're missing? Is it the small firm that we're missing? And if we basically just look at the missings, it's ordinary OLS estimates, but the profit estimates look pretty much the same. We don't see any systematic kind of effect on the size of the factory, on the dummy, whether it's reported or not. The same is actually interestingly true when we look at GDP. So it would argue typically that in the slightly more developed countries, this kind of missings should happen less because they have better statistical offices, they can actually force firms better to be more transparent. This seems not to be the case. Interestingly, if you differentiate between high corporate tax countries and low corporate tax countries, you see, surprise, surprise, there are more missings in high tax countries. So this is the upper quantile, essentially, of the tax bracket we are looking at here. So in these countries, you forget to report turnover, assets, and profits, which is pretty much in line with the tax avoidance literature that would tell you something similar, but not with the missings, but more with what you report. This literature also tells you something about so-called home country bias. So typically, you don't, or the literature indicates that if you do kind of transfer pricing, shift profits around, you slightly do that less in your home country. Probably because there the public outcry is bigger if you avoid too much taxes and don't pay your fair share. So countries seem to do that there less. And in this regard, also what we see here, that in their home countries, actually missings are more likely, fits into the picture pretty well, because whatever you do, you try not to be that transparent, right? You try not to make, if you do something, to create a huge paper trail ultimately, right? So this again fits to this kind of tax avoidance literature findings on the kind of bias side. What we can do as well with our data is to take the data at face value and say, okay, now we have a proxy for firm activity, and this can be used to basically apportion profits around the world. So there's a big literature in the tax, or a big tax discussion in the tax literature, whether this could not just be the better way of more or less taxing firms with some kind of apportionment kind of scheme. And we are basically providing one way of doing the apportionment here by simply saying, okay, we are measuring the entire light emitted by Volkswagen, PSA, Mercedes, Toyota, and we look at each individual subsidiary and how much light they contribute to this overall light emission. And we say that this share of light should then reflect also the share of turnover they're generating for the multinational. So we take the overall output of the multinational turnover assets, or assets are an output, but turnover and assets, and basically reapportion them to the individual subsidiaries. And we call that basically the apportionate output. So this is a proxy in US dollar that tells us how much turnover we expect that a certain subsidiary reports based on what we see that they have on ground activity. And this all should make sense if you really assume that there is no substantial difference in kind of the way you produce cars around the world, which is again the advantage we have here with our very specific industry we're looking at. Okay, and then we can ask, okay, how large is the bias ultimately? So we can subtract from what we apportioned the actual reported output, and we can call this a bias in the estimate, right? And then we can look at what this bias ultimately looks like. And this is just a histogram ultimately of what we're getting out for turnover and assets and profits. And again, we subtract the apportionate turnover, assets, and employment from the reported one, meaning that if they are aligned perfectly, everything should be at zero. But that's not the case. We have a quite bipolar kind of distribution. And in many cases, actually, we have a lot of observations on the right-hand scale, which means that those are firms that basically report no turnover, that report no profits, but they're really, really big. Which is extremely suspicious. For the profit, you can argue, okay, they could not be profitable, but at least they should generate turnover, right? So you have a big factory, there's activity on the ground, they need to sell something, why they exist otherwise. So this is extremely suspicious, and this is also a bit of a kind of warning of caution in this kind of literature that typically puts on the right-hand side assets or turnovers as a size control. So potentially these measures are already in the part of the kind of opportunistic reporting behavior bias in the first place.
Yes, just a question very related to what you're saying right now. It may be the case that you have a big factory with a lot of assets, a big amount, you can capture there with the light of the factory, but the reality is that the profits usually are allocated to the headquarters, because there are the big the heads of the company extracting most of the rent or the profit, if you want, from the factory to their own salaries, benefits and so on.
Or the Cayman Island subsidiary that for some reason exists. And we didn't find any one of those actually for the car manufacturers as far as I considered. That's correct, this is what we would expect. So what we see here really fits to what you described. They make the turnover, but with turnover it's just like, so with profits that makes sense, right? But with turnover that's a little bit of a different kind of story, right? Because you can still have turnover, but you usually would say you have a lot of costs, so there's zero profits. But there seemed to be a systematic distortion of the turnover in the first place, which is new to the literature that so far predominantly focuses on the profits, where we know what you exactly described right now. But what you described is actually interesting because it explains also a little bit the differences between basically turnover and profits and assets. Because what we are seeing here, the most extreme cases are the assets. Right? So the assets there we have -5. So this means that we have a factory that we would say has $1 of assets on the ground, but the reported assets are actually 6 times higher, 5 times higher. Right? And those are these intangible assets that are known in the literature to basically facilitate these kind of profit shifting methods. You have the firm somewhere in the Netherlands that has the pattern to produce a certain kind of engine, which is not available on the free market, so there need to be a kind of negotiation about transfer price agreements, but also about this kind of intellectual property kind of revenues, and this is where the music is in this kind of literature, and this is confirming what we are seeing here as well. So if you look at asset data, you at least should exclude intangible assets if you really want to figure out what's on the ground. But even if you do that, it seems that our data really indicate that you should be very cautious. We have some firms, coming back to turnover and profits, that are very profitable and have actually a lot of turnover, but they have no ground activity ultimately, right? Taking this as it is, we can basically try to get a ballpark number for these kind of distortions that we are facing here. So the one thing is, for example, to calculate the missings. So the naive kind of approach would be to say, okay, we take the total turnover reported or profits and assets by the conglomerate, by the multinational, and subtract from that what is reported in the individual subsidiaries. And this is what essentially is missing, right? And then we come to something like 70% of turnover is missing, 75% of profits, and 12% of assets are missing, right? But then we say, okay, now we know that these reports are potentially biased, so let's use our apportionate profits and turnover and redo this kind of exercise. And then we come to the point that we have 45% of turnover only missing. Sounds a bit strange. I just told you that they hide a lot, but I also told you essentially that the missings are systematically occurring in the high-tax countries. So essentially, this story aligns here. You see that they transport from the places where we don't have accounting data, these kind of economic activity or the reported turnover and profits forward those countries where we have data, which are potentially more the low-tax countries, right? So this already tells you about this kind of distortion. And the biggest one of those is actually the assets. Right? There we actually claim that we observe 12% of the assets, but ultimately with the re-evaluation based on our apportionate data, we just see 60% of these assets. So a huge part of these assets is basically intangible and can be moved around. And in the ultimate reported data, they are in there, but practically we don't see them. The next step here would be then to say how large is this bias, how much is the displacement? And there we come with turnover and profits to something like around 50% or 45%. So 50% of the reported turnover and profits are not in the location where we would expect them if we trust our kind of indicators for firm activity. And this is a huge number, right? Which also corresponds to other estimates in the Nightlight and in the profit shifting literature that my co-author worked on, that also came to vaguely this kind of estimate using slightly different methods for Canada, right? And this tells you that we really should be very cautious when using this accounting data and thinking about using this as an indicator for economic activity in regions. And again, the biggest bias here we have ultimately with the assets, okay? So speaking finally about this kind of bias and thinking about can we explain this bias? So we're doing the same exercise that we had with the missings before. Now we can say, okay, can we explain this bias in the that we calculate here with kind of standard suspicious candidate that could drive the bias? And ultimately, we differ here a little bit from what we did before, because the first thing we are checking here is the light around the factory. It could just be that we have a systematic bias in the data because some factories are more in more brightly lit urban agglomerations, for example, and this drives the bias. So there's a technical reason for the bias that the nightlight data fail us. We don't see that. The same thing is a little bit with the GDP, right? There it could be that in different countries light is produced with a bit of the different technology, so there could be the bias, but it could also be that different countries have harder, richer countries have harder rules, for example, regarding this kind of mandatory reporting of these accounting data. And this we see slightly. So we see that more developed countries, essentially the bias is slightly smaller, but we don't know why, essentially. Interestingly, we don't see it when it comes to the corporate tax rate, and we only very modestly see it for profits when we look at the home country effect. So there we see that ultimately in the home country we have, and this is weak evidence, that we have slightly less bias, which again corresponds to what is in the literature before. But I would not argue here that ultimately this doesn't mean that these biases are not driven by these taxation incentives. Because if you look now at the number of observations, we lose a lot of observations, because now we are not having data on those firms where we miss data. We really have only the data for the few that actually report, and within those that report, the effect seems not to be strong enough to find it here. But we can do one interesting exercise that I like. We can ask about how large is how much of the bias we can potentially explain by country fixed effects and parent fixed effects and the interaction of both. So assume that we have a systematic bias in our data because light is differently used in different countries, or there is basically a systematic difference in reporting in different countries. This should be technically absorbed by the country fixed effect, right? Then we could have essentially a certain bias coming in from that Volkswagen, for whatever reason, reports slightly different than Ford, for example, right? This is captured by the parent fixed effect. And this explains in both for turnover, assets, and profits, something like 50% of the variation. But now comes the interesting interaction. So now we're looking at the interaction of country and parent fixed effects. So this would be a specific effect that tells us how does a car manufacturer A in Germany has a different bias than car manufacturer B in Germany, given that they are belonging to the same conglomerate. So all of these kind of measurement issues with the light data, they should be out, they should not be captured by that, because this is what the fixed effect, the country fixed effects already captures. All the effects that are specific to the parent should be out. What is now really left is this kind of interaction between both issues. And this is probably in reality what is the important thing. So just the average tax rate is not a good, that cannot explain you this bias very well, because in reality it is important how the firm structure looks like. So does the manufacturer A has a very close by production site, for example in the Netherlands, where the tax rate is lower. If they have that, then due to transfer price agreements, for them it's much easier to shift turnover, for example, to the Netherlands. If producer B doesn't have that, it's a bit more complicated. Then they have to go over intangible assets, and so the world is a bit more complicated. And these location paired fixed effects are potentially picking that up. And it's very hard to think about a kind of measurement issues related to the nightlight measure in general that could create similar effects. So my argument would here, it's very hard to measure these kind of incentives for the individual firms for manipulation of accounting data, but with this kind of combination of these two fixed effects, we are capturing that to some extent. We don't know explicitly what it is, but we would capture that. And this adds another whopping 30% to our explanatory power, which is again very close to what we had before with this kind of 40%, 45% of misallocation in the accounting data versus the light data. So this really tells us that there is a very huge amount of this bias that seems to be reasonably linked to the kind of problems of the accounting data rather than to the problems of the nightlight data. Okay, I told you all of that essentially already. That's a quick summary. I think the key takeaway that we try to sell off with the paper is that yes, we can use this kind of micro-level nightlight data as a proxy for firm activity on the ground. We should be aware of the fact that it's better to use it as a proxy for firm size, less so for firm growth, but we also argue that potentially this could be an issue related to our very specific car manufacturing industry that has production cycles of 7 years, and we look at a very small panel. But it is a powerful proxy on the cross-sectional variation, and this can help us to basically shed light on various kind of issues related to political economy. This is the second point. For example, by measuring the different economic activity in different locations, that could be super interesting for development economic issues, by seeing, okay, now we have a measure of what is happening in the specific region. So this is ultimately geocoded foreign direct investment that we have now at our hand. To some extent, but we also can basically talk a little bit, and that's the second point, sorry that I jumped that, or the third point here, we can also now say something a bit more about what we're measuring when we look at nightlight, or what this is proxying. And there the point is that industry lights seem to be proxying something different than urban lights. Okay, I was very fast, but it's a lot.
It's a lot. Thank you so much. Very interesting work. We never expected to have so much information from nightlight and how much we can get from nightlight, and also it's very interesting to get the same data set, twist it around in different ways, and to respond to very different questions as you have done.
Yeah, thank you.
So I guess we may have some questions here, but in the meantime there's one in the chat.
Yeah.
I'm going to read it because the person already is waiting for 20 minutes. It's Jorge Perez and says, hello everyone, not able to use my micro today. Congrats to André for his presentation. and now the comment is, I wonder if the limitations mentioned in the scope of the research due to only short-term closures could be overcome by using the same approach and methodology with data from permanent plant closures due to restructuring and bankruptcies.
So sorry again, I was not fast enough for that. So
I wonder if the limitations mentioned
no, the last two sentences was
could be overcome by using the same approach and methodology with data from permanent closures due to restructuring or bankruptcies.
Yes and no. With that, we ultimately come to the point that there potentially could be changes in the assets, right? It could be that the factories needed to be closed down. It is actually surprising that typically the tragic story is that the factories just stay where they are. So if you look at the Rust Belt in the US, there are entire factories that never have been teared down, that are just standing there. But they are not illuminated anymore. Those are really dark spots after a while. But for in the beginning, if there is a transition period where they don't know whether to produce ever again, they typically still have light on the ground. So this is a quite important thing. And the nice feature here is that we really can separate this capital from this kind of labor component of night. That's why COVID is interesting. The next problem is COVID is a really clear kind of, now they have to shut down. We try to look into firm closures as well, and we try to collect data on whether a firm has been shut down or not, and it happens actually quite rarely. So at least in our time frame that we looked at, in most cases, these factories were then resold to other car manufacturers, and they at least partly reutilized them. So in East Europe, for example, it happened quite a lot. So the number of incidences that you have here to look at are, at least for the car manufacturing industry, not too much, or not existing too much.
Thank you. Yes, everybody fine? Just a quick one to finish, and I'll let you go because now we are late and we may want to talk a few minutes to our PhD students. It's about the measurement error that may be inherent to the data. Mm-hmm. And like, for instance, the reporting data, as you suggested, and in addition to all what you mentioned, is data from 2019. And that accounting data is coming from 2012 to 2019.
Yes.
That's correct. So I wonder if, and then you use for the same explanatory variables with the same time span, correct?
Mm-hmm.
Okay, I had misunderstood. I was understanding that you are using the daylight and the nightlight data for 2020. No.
We're really looking at the panels. So we compare the assets in 2012 with the light in 2012.
Very good. Any other question or comment from the people who are attending our virtual presentation? No? Well, it seems that's it. So thank you so much, André. Thank you for your presentation. Very interesting and very motivating. So we look forward to hear and see how the paper is going to be placed.
How the short paper will look like.
Thank you so much.
Thank you for having me.